Okay, in last session we discussed about creating dimensions, measure groups, and hierarchies, and how to add new measures once the measure group is created, and how to delete the measures, and how to add attributes and delete the attributes. Now, let's see what kind of measures to add. There are so many, what kind of aggregate functions you can use for measures. For example, if you see here, when you try to add a measure, you will find an option called usage. What's the aggregate function you have to set for this particular measure. For example, if you see the existing one which are already defined, if you see the properties, the aggregate function is sum for this one. And you can change it here. Once the measure is created, you can change at any point of time. And once you change it, you have to process, remember that. Or when you are creating a new measure, you can select the option. For example, the sales amount is giving me the amount, sum of sales amount. It rolls up and it will give me the sum of sales. And if you select the count of rows, it will give you, for example, if a product has 50 rows and the total sales sum of those 50 rows is $150 and the count will be 50. It will give you the count of rows that are there for that particular product, and let's see how it looks when you browse the data. Now I created one more measure which will give me the count of rows. How many rows are there for a particular combination? For example, if I drag and drop due date month from due date, then if, let's say February. For February, if there are 50 records in my fact table, then it will give me 50 as output. Let me process this. It's processed successfully, and let me browse the data now. Now I'm dragging both the measures. Let's say the sales amount and sales data count. If you see the total sales amount for that is there in that particular fact table called fact internet sales is 29358677.2207, and the number of rows that are there in that fact table is 60398. And let's see some combination. For example, if you take due date wise, or if you take for an year, you have many years data. Let me drag 2004. Sorry, you have to drag this here, and you can see for 2004 this is the sum of sales and this is the number of records. And let's see the same in our database to find out whether I'm getting the correct data or not. You know how to write queries for this, and let me write a simple query to get the similar data in SQL Server Management using SQL queries. This is the database, and my requirement is select sum of sales amount, count of number of records from fact internet sales joined with dim time on dim time dot time key is equal to fact internet sales dot due date key, group by calendar year. I have to give the same here. Or if you want to filter as you are trying to check the data for year 2004, you can filter out that. You see the data 1042325 top 5 and 3429 records. So it is exactly matched. So the functionality of count will give you the number of rows that are there for the particular row item. In this case, the row item is here. In this year, there are these many rows, and for the year 2003, there are 22596 rows. Either you can make use of count, and where you will use this. For example, let me create a product dimension. I'm creating a product dimension, and I want to see the count of products. Okay, so I don't have key defined there, so I have to write this header here. And let me take English product. And I want to see how many products are there per product. I mean, for each product in the product table. In that case, what will be my measure? My measure will be count of products. So I have to add new measure, count of rows of not sales data but product table data. Okay, I created that and I added. I have to add cube dimension here. Now the relationship is set. This is taken as a regular relationship, but you know when a relation, I mean, you can, okay, let's just leave it as is and we'll come back to this. And let me process this now. Now if you try to browse the count of rows from dim product, if you drag this measure, if you drag this product, it should be 1111. Why? Because each product will have only once, except one or two which is repeated. Let me write the same query here. For a product, how many rows will be there in the master table? There will be only one row. So let me write the query and check that. I have to join with the team product. Product key is equal to fact internet sales dot product key. And now I have to use this. So group by English product. To run that, oops, it is not from fact internet sales. So I'm extremely sorry, I'm confused. From dim product table. I'm trying to get the count from dim product table. How many records are there per English product name? You see, it is giving me the same. And it is of no use if you see. Per product there will be only one table. Then what's the use of, how can I make use, how can I count this? How can I make use of this count per product table? So if you want to see how many red color products, there will be more than one red color product for sure. How many black color products, how many blue color products. In this case, you can make use of this count per products. So product table, if you simply run the select statement, in the first case, what we try to see is dim product. This is the product name. This product name will have only one record here. Second product name will have only one record. Third product name will have only one record. And there are few product names which are duplicated. So you are getting 3 or 2 sometimes. So this one won't make sense. But if you see color, if you see color, there are many products which are black in color, which are silver in color. So this count will be useful whenever you are trying to see the data, like how many products, or you can do one thing. You can see per product how many tag records are there. Let me tag color, and black color one, there are 130 products, and blue 28 products, gray 1 product, multi-color 18 products, not applicable 254 products, and in total there are 664 products. Okay, this is how the count works. And if you see, there are so many other kinds of aggregate functions that you can use. The third one is count of non-empty values. It will count only non-empty values. If there is any empty record, it won't count. It will exclude that empty and it will count the remaining. The minimum will give the minimum value. For example, if I have sales like $50, $100, $1,000, and $1, the output of that particular row item will be $1. Maximum will give you maximum value. Distinct count will give you distinct count of those. For example, if you have a same product again and again, or for example, you can set this one on any column, and if there is on any table, and if there is this duplicate record, it will ignore that and it will give you the distinct count of the record. It is just like writing distinct count in SQL query. No aggregations, it won't set any aggregation to show as is data. And the account is not it's a new one, it's not. I'm not aware of this. Average over time, first value, last value, first non-empty, and last non-empty. These four are called semi-additive measures. First value, last value, first non-empty value, and last non-empty value. The first value will give you the first value. The last value will give you the last value that is there for that particular combination. For example, if a product has 500 transaction records and you are writing this first value on top of sales amount, then it will give you the first amount. Okay, first amount, let's say it is $50, it will give you the 50 as the output. If you give the last value, it will give you the last value. And semi-additive measures, these measures will add up whenever you are running the query against any dimension, but not against time dimension. When time, if you take this last value, if you have, you will have every day twice data. If you take last value, it will give you the last value only. But for other dimensions, it will aggregate and give. And these are the two types of measures we have, that is additive measures and non-additive, semi-additive measures. Semi-additive measures, as per the definition, it won't aggregate for time dimension, and for the remaining dimensions, it will aggregate and give you the data. Okay, these are all the different types of aggregate functions you can select on top of a measure, for a measure. Now, let's see some important concepts, the heart of SSAS. Next to data source view, this is the important concept of SSAS, that is dimension usage. This dimension usage tab is useful to give relationship between dimensions and the measure groups. We discussed in last class that cube is nothing but collection of dimensions, collection of measure groups, and relationship between these two. Now I have collection of measure groups, that is sales data and team product, and I have a collection of dimensions, and relationships are given as it is given in the data source view. And if the relationships are not given in data source view, then you have to give relationships here. Okay, so this is very important page, important tab, and I demonstrated what will happen if the relationship is not there. For example, for this dim product count, we have count measure on the dim product measure group, and this is not related to any of the dimension table, any of these time dimensions. So let's see how it shows the data. For product, it is showing perfectly. Why? Because these two are related, dim product and dim product is related, and the measure is from dim product measure group, and this color is from dim product dimension. Let me drag something from date, which does not have a relationship to the fact table. Let me drag here. What will happen is it will show 606, 606, 606, 606 for everything. It will show the same value, that is aggregated value, to all the years that are present in the dimension attribute. So if you don't have relationship, then it's of no use. You can't say that the cube is done. For example, if you have 15 dimensions and 2 measure groups, and if you give only one relationship, one dimension, relationship between one dimension and each part, each measure group, then the remaining 14 dimensions are of no use. You cannot make any analysis based on the remaining 14 dimensions. In this case, you cannot analyze any sales data using dim product dimension. In this case, you cannot analyze any dim product related measures data like count we have in this case using attributes from time dimension. We have 3 role playing dimensions here for the time, and you can ask. Now let's see what are the types of relationships we have and how to give each one. Let me click here. How to give relationship. First one, you have to click on the particular cell. You will get a button, and you have to click on it. You can see the different types of relationships, and there are no relationship, regular, tracked, referenced, many to many, and data mining. And you know no relationship. If you don't have relationship, you have to give no relationship. And as I told you, it is not mandatory that all the dimensions and all the measure groups should have relationship. If my requirement is to analyze color-wise products count, then why I have to give relationship to the time? I don't need it. Okay, so to dim product measure group. In that case, what I will do is I will give no relationship so that it will take less time while processing, and it will create less number of aggregations, and it will save memory and time. Okay. Now, first let's discuss about the relationship types we have. The first one is no relationship, which means there is no relationship between the dimension and the fact or measure group. The second one is regular. It is nothing but a straightforward relationship. When you have a direct relationship between dimension table and the fact table using foreign key, then we call it as a regular relationship. And the best example for this one is star schema. If you take star schema, the fact table or measure group table will be directly related to all the dimension tables. So that means for that particular measure group, all the dimensions are related using regular relationship. And the third one is fact relationship. When the dimension table and the fact table are the same, I created a measure group using dim product in this case. You see here, I created a measure group using dim product. Okay, and the measure name is count. And if you see the dimension, I created the dimension using the same table, that is dim product. So in this case, dim product and dim product both are, measure group and the dimension are using the same table. In that case, the relationship between those two is fact relationship. And the fourth one is reference relationship. We heard about snowflake schema. First, I added all the related tables to my fact table, and I will show you with an example. If you go to the data source view, let me do this one is regular in relationship. The fact table is related to all the dimension tables directly. And if I add tables that has relationship to the fact table, that has relationship to the dimension tables, I will get new set of tables here, like match bowlers pack, user matches, group matches, match fielders pack, something. And if you see, let me arrange it. This is our fact table, match pack contact. This is related to players, and How this match batsman fact and match bowlers fact are related? Through layers. Okay, this is a bit confusing. We're getting more more fact tables into the picture. Let's go with adventure works. Let me add it. We remove the relationship. Let me set the relationship to give clear picture. Product key is related to dim product using product key. Now these two are regular in relationship type. Now if I add any table that is related to, oops, everything is named query there. Okay, let me add dim product subcategory into this. Here it is. And we have relationship between dim product subcategory and product to dim product subcategory. Now this fact table is related to the dimension table using regular relationship. How these dim product subcategory and fact internet sales are related? These two are related to some other table, some other dimension table, that is dim product in this case. And when the table is related to, when the dimension table is related to the fact table through some other dimension table, then we call it as reference relationship. Okay. Now let's go back and see. And many to many is a typical one, and we'll discuss about it when we finish discussing about the first four. And data mining is purely related to the data mining concepts, which is not in scope for this session. Okay, let's see how to give each relationship and how to modify and how to set the relationship between the dimensions and the fact tables. Okay, the first one. No relationship. Everyone is aware of that. And let's see how the regular relationship. If you say dim product and dim product, these two are fact relationship. Both are defined based on same table, same data table, that is dim product. So this is fact. By default, it is taken regular. Okay, fact. It has taken regular, and let us change it to fact table. Or better, I prefer to do this. I will remove all the relationships. And let me add other dimensions, and let's view the relationships. You'll get clear picture. So dim product will be sales territory. Don't have a key column, and I'm giving key column here. And sales data region, country, and group. I want to analyze the data. Okay, sales data is done. And let me add customer. See the headache. If you don't have designed the data source view properly, you have to give all these things manually, or else it's damn easy to define all these dimensions. It won't take this much time. In time you have in currency, let's go on define dimension for in currency. And I'm giving currency name. So I'm giving name column, so I don't need any other attribute here. The same thing will give me currency name. So better to give a proper name here, which will give proper meaning to the end user to drag and drop. And new dimension, dim product subcategory. It has primary key defined there, and English product subcategory. Fine. Now I have all the dimensions defined. Let me add all those things to the queue. Currency I want, customer I want, product already selected, product subcategory selected. Okay, cool. Now everything is there. Product subcategory, there is a relationship to the dim product. That's why it has taken by default. remove that and let's add some stuff. Okay, how ship date and sales data is related. These two are related through regular relationship. The key column is ship date in fact table, ship date in fact table, and time key in dim time table. So it is regular. What is the granularity in your dimension table? Granularity is attribute is nothing but the attribute that you are using to join. Okay, time key in that one, and here it is ship date key. You have to select these two, the measure group columns and granularity attribute, and click on OK. The regular relationship is there. Let's implement the same in data source view. In SSMS. Select start from part internet sales, inner join, dim time on dim time dot time key is equal to part internet sales dot ship date key. I'm trying to get ship date related data. So if you see here, my path table and the dimension table are directly related with one inner join. You are defining this inner join using the wizard that is open here. Maybe confused. See, this is what you are defining. This is the path table you are giving, and this is the dimension table you are giving, and this is the time key you are giving here, and ship date key. This one will form the inner join kind of query between the dimension table and the fact table. So this is called regular relationship. When the dimension table and the fact table are directly related, and in database level it's just a simple query, inner join query. And this is how you have to give regular relationship. Okay. Now let's see. I want to get the product subcategory wise data, internet sales or sales amount. Then what I have to do? I have to join with product first, or because I don't have direct relationship between product subcategory to pack internet sales in this case. So I have to join with the dim product. Product key, pack internet sales dot product key. So this is directly related. Dim product and pack internet sales are directly related. So here we have dim product and this is internet sales data. So we can give regular relationship for this. Right, select regular. Granularity, what is the granularity? The join key column. It is product key from the product, and from measure groups the same product key. Now the regular relationship is set between dim product and the sales data. Now what you will do to give relationship to dim product subcategory? You have to write one more inner join. Dim product subcategory on dim product subcategory dot product subcategory key is equal to dim product dot product subcategory key. Now if you see, the dim product and the pack internet sales are directly related, and this dim subcategory and the pack internet sales are related through dim product dimension, dim product table, or related through some table. That means if I comment out this, if I don't have this join, then this query doesn't work. Which means that if I don't have this dim product in the middle as reference, then I cannot pull and see the data from dim product subcategory and pack internet sales. Okay. Now let's see how to give this reference relationship type in SSAS. Dim product subcategory has reference relationship through product. So when you want to define a reference relationship between a dimension and the fact table, in this case sales data is the fact and the dim product subcategory is the dimension, then you must and should have to define the intermediate dimension. If you don't have intermediate dimension, then you cannot give reference relationship. So you have to select reference. Here you have to select the intermediate dimension. What's your intermediate dimension through which it is going to connect to your fact table. So dim product is my intermediate dimension. How these two tables are related? I mean dim product subcategory and product category. I'm going to give this query, this part of the query here. What is the intermediate dimension table? It means it is dim product, and how these two are related is through product key, dim product key. Product subcategory key, and here intermediate dimension attribute, if you see there is no product subcategory. Why? Because I have not selected that as part of my attribute list. You see the attribute, whatever the attributes that are available, you can see only those attributes. So even though I don't need this product subcategory key for my analysis, but I need that one for giving reference relationship between dim product subcategory table and my fact table. So I'm taking this one, and once you add any attribute, no need to process or no need to do anything to show it here. I'm selecting reference type. Dim product is my intermediate dimension, and these two intermediate dimension and this particular dimension are related to product subcategory. Now we can see it, and make this one as check, and you will come to know why we need this material. And this is the icon which says that this is reference relationship, and if there is no icon, then that is regular relationship. Now if I drag any attribute from dim product subcategory dimension and I measure from sales, it will get data like this. It will check the relationship here, it will go to product, and it will check the relationship, it will get the data. Just like the query what we have written here. So here you can get easily English product subcategory name, comma, sum of sales amount. Group by English product subcategory. Now if you see, it's working fine, and this is my intermediate dimension in SSAS point of view, the product. And how it will do is, it will come here, it will check the relationship, it will go on roll up to product level, and it will give you the English product subcategory level data. This is how to give reference relationship. Let's add one more table which will have reference relationship. And okay, now here I'm unchecking this materialize option, and let me give fact relationship, different fact relationship, and then let's process the cube and see whether the data is working fine or not. And which one has fact relationship? Dim product measure group and dim product dimension has fact relationship. If you come here, if you select the fact relationship, that's it. If these two are really related, these two are made of same table, automatically it will take. Why? Because this is my dimension table, this is my fact table, the same is fact table, and both have the same primary. You no need to specify that. I mean granularity attributes here. Now we have given we have given four different kinds of relationship. One is no relationship, another one is regular, another one is reference, and another one is fact relationship. If you see here, avoid non-materialized reference dimensions. I uncheck that materialize option. Okay. Now let's process and see whether it throws any error or not. it processed successfully, and to come and browse. This dates does not have relationship. This thing product fact data has relationship to only product attribute through using fact relationship provided that it is working fine. Let me check the sales amount. These two are related, so it is giving sales amount correctly. And we use reference relationship for English products or category. You can see the same data as what we are getting here. So let me add one more table which will have relationship in terms with the DIM product subcategory table. That is our DIM product category table. Let me add that here, or I can directly use this. If I click on that, it will list me what are all the tables that are having direct relationship with it. I know product has, but I don't want. I use name query to define the product, and already it's in use. I want DIM product subcategory, which is having relationship to your DIM product subcategory. If you see, this is how it is related. If you ask if anyone asks you how DIM product category is related to packed internet sales, I have to say it is related to two different dimension tables. One is product subcategory and another one is DIM product. Now let me create a dimension for that. DIM product category, key column is selected, nearest product category name, and done. Let me go to the queue. What I have to do? The first step is add the dimension here. Product category, come here and give the relationship. Which relationship it will take? It will take reference, but reference through not DIM product. In this case, it will go through DIM product subcategory. If you write the query for the same, it will be one step more. One more image. DIM product category is joined with fact. So better to have this. Is joined with the product subcategory using product category. Okay, and English product category. We can use this. We can see product subcategory wise also. It has relationship and it will give you the data. But here, let's see the next level. It has three different categories, that is clothing, bikes, and accessories. So if you ask how this one is related to fact data and how it is giving fact sum of sales from the fact table, then this one will go to DIM product subcategory, and this one will go to product, and this one will go to fact sales, and it will give you the data. Now you have to give reference. What is the intermediate dimension? It is subcategory. And when you select this, it is showing some warning message. The relationship is defined through one or more reference relationships which are not materialized. So defining chains of reference relationship requires that all participating relationships to be marked as materialized. The following dimensions must be marked as materialized in product subcategory. What it is trying to say is, this is your direct relationship and this is your first level of reference relationship. So until first level, it is fine. It lacks the non-materialized one. If you are going to use this dimension which is referenced through some other dimension to the fact table, if you use that one as intermediate dimension for another reference relationship, in that case this relationship should be materialized. If you check on materialize, it prepares the query in a different format. While analysis services process the data, it will create the query in a different format. It will create a copy of this table in product tables. So that's the advantage, that's the reason. Now, if I check that, I can give reference relationship to DIM product subcategory. It is not showing any warning message. And what is the relationship? How the dimension table, reference dimension table and intermediate dimension table are related through product category. Here there is no product category, and the reason is I have not selected it as an attribute in my dimension. So I have to select product category key and come back here So this is why you have to come back and go back again and give the relationship. If you don't define the dimensions, if you don't know the business logic properly, then you have to come here and go back. You don't know which relationship you have to give for a particular dimension and the fact table. If you have complete knowledge about the business and the database, then you can easily find out what are all the key columns that are required for giving the reference relationships. Now, the key columns are product category key and product category. If I uncheck this, then I can unsave this. So, if a reference dimension, if I am using a dimension as if my intermediate dimension is referenced to some other dimension to the fact table, to connect to the fact table, then everything should be materialized. And now if I add one more high level hierarchy higher than the product category, and let's say product types on top of that, then I have to materialize each and everything to give reference relationship to product types through product category, which is using reference relationship through product subcategory, and which is using reference relationship through being product to connect to the fact data or measure group data. So this is how we have to define the reference relationship, regular relationship, and fact relationship. And I mean, we know these are regular relationship. These are having regular relationship, having direct relationship to the fact table. So let's give that. In this case, time key, and this is for due date. So the measure group key column is due date key, and this is regular relationship, and the key column. Sorry, I selected reference. So the key column, the granularity attribute is time key, and here order date key. And in currency, you know how this is related. This is direct relationship. We remove all the relationship. Regular currency name. Why? Because it is the currency key. That is the key column, but name is the display name column. And here it is currency key. And then customer is again directly related. So regular customer key, and here it is customer key. And sales territory, it is directly related. Sales territory key to sales territory key in the measure group table. And this is a product table, and I am going to see product wise, din product wise data, and this is fact related. And you know this product and this subcategory has a relationship. So you can use reference relationship, and what will be your intermediate dimension? Din product, and to subcategory and subcategory. You see here, I don't bother whether it is regular relationship to the fact table or not. This dimension and the fact is directly related or fact related. That doesn't matter for reference relationship. Reference relationship will check whether it has any regular relationship or reference relationship or fact relationship to the measure group table. And if it is having that relationship and these two are having relationship, then you can set the reference relationship. So what I'm trying to say is, it doesn't matter what the end dimension table, how the end dimension table is related to the fact table. It may be through fact or regular or reference, but not many to many. Okay. Now these two are related, this dimension and this dimension. So I have given reference. In the same way, these two are related. You can give reference between product subcategory is the intermediate dimension table, product category key to product category. And now you will come to know what the use of this count in the same product. Let me process this first. If you see, when you add so many relationships, the time taken for processing the cube will be increased. So it has to process all the possible ways and store the data in your aggregate data in your analysis server. So if you see here, I'm reconnecting. Let me erase all the data. This is eraser. Dim product, it was giving just bullshit when I dragged product name. Like 1, 1, 1, 1, Okay, I have given reference relationship to product subcategory and then product measurable. Now to drag that and to remove this one will give you better idea. How many types of products are there under jersey? How many types of products are there under mountain bikes? How many types of products are there under mountain bikes? This is how. And if you drag product category, it will give even better picture, which will be useful one. How many types of product categories are there? How many types of products are there which belongs to the category accessories? So this one is helpful if you have a higher hierarchy. Then the table that you use to create the count. Okay. So this is how you define a regular, reference, path, and no relationship. And let's see how the data should be. Now if you see here, in one case, no relationship between the table and the fact table. Let's say this is the dimension table and the fact table. No relationship at all. In the second case, both are same, fact relationship. So the dimension table and the fact table are same, that is this one. The third one, a regular relationship, these two are directly related. And in the fourth one, these dimension table and the fact table are related through some other dimension table. Okay, or even you can have one more dimension table, and this dimension table is directly related to the fact table using two intermediate dimensions. Okay, these are different types of relationships what we discussed, and these are the maximum possibilities what can be available. Let me explain you one more way. The first way is no relationship, everyone knows, and ID, name, marks, 1, 2, 3, 4, 5. Group. I have 5 different students. Each student marks 45, 45, 45, 20, 56, 56. These are the marks scored by each person. In this case, if you see, if my requirement is to see the marks of a student, what will be the fact table and what will be my dimension table? In this case, the dimension table is the same table as the fact table. And the measure is marks here and the attribute is name here. So these two will be related using fact relationship. Okay. Using this one, what you will get? You will get only one subject marks. You are not going to get more subject marks. Let's say I am keeping a different table for marks. This is my master table. We call it as our dimension table in SSAS. And here ID, student ID, and marks and subject ID. 1, 1, 1, 1, 1, 1. 6 subjects, 1, 2, 3, 3, 4, 5, 6 subjects. We'll have 6 subject marks. These are the 6 subject marks, like that for every student. If you see, 1, 2, many will be there. For one record in this table, that is ID 1, there will be many records in the child table. So this will be my fact table and this will be my master table. So this is one to many relationship and we call it as a regular relationship. And you have one more level on top of this, like ID and student type. 1 grade A, 2 grade B, like this. And here what I will have? I will have student type ID. This is how the database will be. So for Rupesh, the student type ID may be grade A, for Lokesh grade A, for Vinay grade 2, grade 2, grade 2. So how these two will be related? Using through this table, that is reference. So if you see here, this is my fact data, and this is linked to this one, that is regular relationship to this one. I can see the student name wise marks here, and these two have relationship through this channel and here. So if you want to see grade A student, I don't bother who is, whether it is Rupesh or Lokesh or Vinay. I want to say grade A student marks. In that case, it will come here. I will have to give reference relationship through this table, and it will come here. It will take the students who belongs to grade A, that is Rupesh and Lokesh in this case, and it will get the marks of these two students. So this is how the reference relationship and all. Now let's go and see the fourth possible way of having data. I'm deleting everything. And the best example is books and amount, sales, authors. If I have author ID, author name, 1, 2, 3 authors are there, and name is name 1, name 2, name 3. I have 3 books. One, two, three. C, C++, Java. Okay. Now, let's say this is not one-to-many relationship. The same author can have 2 more. I mean, might have written 2 to 3 books, or many books, I can say. And the same book can be written by many authors. For example, if you say author name 1 has written C and C++. Name 2 has written C++ and Java. Name 3 has written Java and C. So for every author there are 2 books, and for every book there are 2 authors. So this kind of relationship is called many-to-many relationship, and you can't set using reference kind of one-to-many kind of. So in this case, what you will do is you will use an extra table without any fact data, which will have only IDs and like author ID and book ID. What you are going to relate here is this particular author has written what all books. According to us, it's C and Java. Sorry, C++. Author 2, author 2, author 3, author 3. Author 2 has written C++ and Java. Author 3 has written Java and C. So this is how these two are related. And my fact table data will have any one fact data. For example, let's say book-wise sales I have. I can't maintain both the sales. If I have to maintain both the sales, like author-wise sales and book-wise sales, then I have to add sales amount here. What will happen if I have $20, $30, 33, something like this? For 2 books, 3 books and 3 authors who has a many-to-many relationship, you got 6 records. Imagine if you have 1 crore authors and 1 crore books. It will be damn huge. It is a factorial kind of. Sorry, it's a cross multiplication. One author, if he has 50 books, you will have 50 IDs for that. And the same book has many authors, you will have separate IDs for that. So it will end up in huge data. Like you can change that by way you are storing the data. Instead of storing the sales amount here, if you store the sales amount here, like book ID and sales amount, then book ID 1 sales is $200, book ID 2 sales is $300, book ID 3 sales is $100. I'm storing the data at book level, the sales amount at book level. Now, if you run this and relate these two, if you see the book-wise data and this one, these two are directly related, regular relationship. And this one is related to this table, but not to this pattern. So you can set relationship between these two, the dimension table and the fact table, which is not having direct relationship or not even reference relationship. What will happen is, it will come here, it will join with author ID, it will take the book ID from there, it will go here, and from there it will come to book ID. So it is using many-to-many table. That's why we call it as many-to-many relationship. Let's see, if you create a dimension with this table and measure group with this table, then if you run this, if you drag book name and sales amount, it will be for C, it will be 200, for C++ it will be 300, and for Java it will be 100. Okay. Now let's assume let's see how to see the data for author by author name wise. So for author name 1, it will come here. For author name 1, this is 1 is linked to 1 and 2 books. Author 1 has written books 1 and 2. So it will come here and it will check what are the 1 and 2 books. It is C and C++. It will go here and it will check the sales. What is the sales of C and C++? It is $500. So like that, it will give you the data. It will come here to the many-to-many relationship table and it will take the IDs and it will go back to this one and it will get the data from your fact table. And let's see how to configure this in how to define many-to-many relationships in SSAS. For that we have to define tables. I'm not sure whether I have tables or not. Let me check that. No, I don't have address. I have some tables somewhere. Might be in Cricket database. Let me check that. Okay, we have books here. Let me select this database. We have books. As I told, I have C, C++, and MDX, and authors is there. And there should be related table for this one, right? Many-to-many table. I think I've given it as auth books. Here it is. And the fourth one is our fact table, given the name as sales, I guess, book sales or sales. Here it is. If you see this data, have 3 books, 3 authors, and each author has written 2 books, and each book sold twice. $200 for book 1, $600 for book 2, and $800 for book 3. Now let's design the data source. What are all my dimension tables in this case? My dimension tables means it will give me textual data. Where I find textual data, I can find it in authors and books. So those two will become my dimension table, and this is my fact table where I am having metrics. And what is this intermediate table? Let's discuss about it. So I have the data in Cricket data source view. Let me add that. I have the list tables. Authors is 1. Author books is 1. Books is 1. And there are so many. Sales is 1. So I added 4 tables. Now what are all my dimension tables? Authors and books. Dimension. I have to create 2 dimensions. I have to select the data source view first and here first for authors. And I will use name column so that I can eliminate one extra attribute that is required. Okay, name column, I'll give a name here, and authors is done. Next one is books. So I created two dimensions. Now I don't have a cube which is pointing to cricket test data source. Cricket data source view. I have only one cube defined which is pointing to adventure works. I can't add these dimensions in this one. Why? Because these two are pointing to different data source view. I can't see the dimensions which I created now. So what I have to do is I have to add a new cube. I can add an empty cube pointing to cricket data source view. Next and finish. Now let me add those two dimension tables. Now my dimensions are ready. I give fact. What is my fact table here? My fact table is art books. This one. Sorry, not art books. My fact table is sales. So if you see here, we have direct relationship to authors. Is it authors or books? It's a book ID. We have direct relationship to books table and sales table. So I've given relationship book ID to ID. Now these two are related. If I process it, I can see book wise data. Let's process and see whether it's giving correct data or not. According to the database, each book is having first book is having 200, second book is having 400, and third book is having 800. So let me drag books first. ID I have not renamed it, and measures it is sales. So it is 200, 600, 800, and it's the same 200, 600, and 800 for three books. Now, how to give relationship between these two? Okay, you know these two are many-to-many related. So let's try by giving many-to-many relationship. It is asking for intermediate measure. What is measure group? We know about intermediate dimension, but it is asking for measure group. So we have one intermediate or bridge table kind of thing, which will have only key columns. That is auth books. It has author ID and book ID. It will have relationship to two dimensions. Okay. Now that table is called as bridge table or factless fact table. It's a very important word, factless fact, which means it will have it acts as a fact table, but it will not have any facts, any measures. Let me add that. New measure group, auth books. Sorry, I wanted the wrong one. New measure group, auth books. And if you see, it has only ID, and every ID is integer. That's why it is showing here. Actually, you will have auth books count only. It doesn't have any fact columns like sales amount, that amount, this amount. No fact, no measure columns, no metric columns. It has only columns to relate two dimensions to a fact table. Now, you know this table, this measure group is directly related to both the dimensions. Using ID, it's related to authors using author ID, and related to books using book ID. Okay. Now, this should be the scenario for using many-to-many relationship. These factless fact tables should have relationship for both the dimensions, and one dimension should have direct relationship to direct or reference or fact relationship to the measure group. The scenario is there. This is directly related. I can see book wise sales data, and this is related to this fact is related to both the dimensions. In this case, you select many to many and the intermediate measure group will become the output which has relationship to both the dimensions. So if you see here, for authors, it will come here, it will take the IDs, it will check these IDs, it will come here, it will go to sales. And let me show you that here in this one. This is the data we're having. Now this is the sales amount. These two are related and fine. And these two are not related. And these two are related and these two are related. So I have given the same here. First I related these two, this books dimension with this measure group, which is this one, this to this, and this author books to both authors and books, which is, this is the first case we discussed, and this is the second case, and this is the third case. Now indirectly this one has a relationship, but you have to specify what is the table which has relationship. In intermediate, in reference dimension we are specifying what the intermediate dimension table. If this is related to this fact table through this table, then we are giving that. We are giving that. Here in this case, what is the intermediate one? This is the intermediate one, which is helping in setting the relationship between author and the sales amount. So you have to specify that in your many-to-many relationships, and this is the icon for that. And let me click and show you. Click here. This is the intermediate dimensions, intermediate measure group that you have to. This is how you have to define many-to-many relationship, and this should be the scenario. There should be a intermediate fact table or Factless fact table or bridge table, to call it as in many ways. And if it is the case, then you can give relationship, many-to-many relationship. Now if you see, we set the relationship here. You know this is the book-wise data, and let me see author-wise data, whether it's coming correctly or not. Author Lokesh has 800 sales amount. Let's see in database whether it's correct or not. Lokesh is ID 2. ID 2 has written book 1 and 2. This is the ID 2 author ID has written book 1 and 2. 1 and 2 sales is 200 plus 600. That is 800. Correct. And the second one is book Rupesh. Rupesh is ID 1. ID 1 has written book ID 1 and 3. Book ID 1 is 200 sales and this one is 800 sales, which is 1000 sales, which is showing perfectly. And the third one is Vinay. Vinay has written book ID 3 and book ID 2. So 400 plus 400, 800 plus 300 plus 300, 600, that is 1400. So it is working perfectly. This is how. And suggestion is, do not use many-to-many relationships. More many-to-many relationships unless and until the situation demands and the requirement demands. If there is no other go to give relationship between the dimension table and the fact table, in that case you can go with many-to-many relationships. And that too, if your dimension tables are huge, then try to avoid many-to-many relationships. For example, if you see here, this one is coming here. Sorry, one second. This one is coming here and checking in this list and going here and coming here. Correct? These are simple dimensions with 3 to 3 columns, 3 to 3 rows. Let's say this one has 1 crore records and this one has 1 crore records. This combination will be having something around 2 crore or so, something around that. So it has to come here, cross join and check the 2 crore records and pick the set of records, come here and check in the 1 crore records and go here and check in 50 crore or 100 crore of records. So it will become a big headache. It will lead to performance issues. So better avoid many-to-many relationships when the dimensions are huge. Try to find some alternative way. If you don't have another go, then last step is to go with many-to-many relations. That's it, and this is how you can give different kinds of relationships between the dimension tables and the fact tables, and we covered regular relationship, path relationship, many-to-many relationship, and reference relationship. Let's take a small break and let's come back and discuss about few more objects of SSAS. Okay, if you see, there are so many tabs here, like calculations, KPIs, actions, partitions, aggregations, perspectives, translations, and browser. Let's discuss about few concepts today. Like let's start with partitions. Partitioning of data. This is very important to improve the performance of the queue processing and as well as querying the data using MDX. You know that when the cube is ready, Monad database is ready, you will use MDX queries to pull the data from your cube database. It is just like TSQL for SQL Server, Transact SQL for SQL Server. In other words, that's a querying language to pull or to query the data from cube database, SSAS cube database. So, why we need partition? The main reason, it increases the processing performance time. It decreases the time that takes to process the queue. For example, let's say you have 50 crore records in your fact table and you have all regular relationship sets to your dimension table. And if you click, whenever you add a measure group here, for each measure group, one partition will be created by default. Like this, I added two measure groups, one is DIM product and another one is sales data. So one partition is created. And partition is nothing but the container where you are going to pull and store the data of the fact tables. Okay. And if you see the partition source, it is table binding, which means it will pull the complete data from the table and place it into your analysis server after aggregations and all. So for sales data, by default, one table binding partition. For DIM product, by default, there will be one table binding partition created whenever you create a measure group. What will happen is, let's assume if you have 50 crore records in your sales data fact table, when you click on process, it will read each and every record through this partition, and it reads like 1 lakh record per second. Imagine how many seconds it will take to read all the records, all the 50 crore records, and after that it has to create aggregations and it has to create views on top of it. So it will take a bit of time, like some seconds. If you assume 1 lakh record per second, it will take some good amount of time to read all the records from the fact table. And if you create more partitions, then you can enable parallel processing. Means it will pull data through many partitions at a time. Like it will improve it will take less time to process. For example, let's say in real time, in my experience, if the table is having 30 crore records with single partition, that is table binding, it will take 3 hours to process the data, and it again depends on the dimensions and the relationships what you set. And if you create partitions on top of that, then the same thing will be processed in 1.5 hours. Okay, as I said, it's again depend on the dimension size and the relationships. So the first advantage is the processing time will be decreased. The time taken for processing the cube will be decreased. And let's see how to create the partitions. And the second advantage is whenever you query the data. For example, if you have sales data for 10 years, and you create partition for year-wise, partition year-wise. For each year, you create one partition. So whenever you query data and add a where condition in your MDX query, filter the data like where year is equal to 2001, it will come to that particular partition and it will fetch the data from there. Which means 10 years data, you have 50 crore records, which means you have 5 crore records per partition on an average. Instead of going through all the 50 crore records and fetch the data, it will go through 5 crore records and pull the data if you have where condition. Whenever you are having a filter condition in your queries, then it will be faster. It will retrieve the data faster. Now let's see how to create partitions. And there was a limit set in 2005 that you can create only 2000 partitions per measure group. Now that limit is removed, you can create any number of partitions per measure group. And on what basis you have to create partitions? That's a very important one. The key point that you have to remember when you are creating partitions is you have to partition the data in such a way. You have to find out the most frequently using filter condition. How best you are gonna categorize your data. Like year-wise is the best fit. If you feel that, then you can create the partitions year-wise. And if you feel the product-wise, you have so many products, and you can create product-wise partitions. And if you're gonna fetch the data frequently using the product filter, then it's better to go with product-wise. And the next point to be remembered is while creating many partitions on a measure group, you have to make sure that you are not gonna miss even a single record from your fact table. If you miss one record, then $100 or $200 of sales amount is gonna miss from your analysis part. So you have to make sure if you have 50 crore records exactly in your data warehouse fact table, then you have to write partitions in such a, you have to create partitions in such a way that all the records are fetching, all the 50 crore records will be fetched into the queue database. Okay, let's see how to create partitions. If it is table binding, only one partition will be there, which means it's a table, complete table data will be pulled into your analysis services. So if you want to add more partitions, then you have to change this one to query binding. Once you change it to query binding, you can see the select statement, and at the end there is a where condition. Partition is nothing but pull some kind of piece of the data from your fact table and put it into one container. So I can get piece of the data or slice of the data using where condition. I can slice using where condition. How shall we partition based on? I don't see any good column here to partition the data. I will show you an example by taking sales amount. Okay, sales amount is less than $1,000. This is to check the query whether there is any syntax error, successful, and click on OK. Now this partition sales data with amount less than $1,000 will contain all the fact records where the sales amount is less than 1,000. And this is the button you have to use to create new partition for that. Click on next. On sales data, here it's listing all the measure groups. Want to create partition on sales data. Already one partition is created to fetch all the records with sales amount less than 1,000. Now, finding the table, this is the sales data table. Click on next, specify the query to restrict the rows. Again, the where condition, where sales amount greater than or equal to. The first case I have given less than, so it will give up to $999 or $999.99, and here I have to add $1,000 too. So greater than or equal to 1,000 and sales amount less than 10,000. So syntax successful. Go to finish. Design aggregations and partitions. For the partition now, there's design aggregations later, and give a name for this. Sales data with amount between 1,000 and $10,000. Finish. Now one more partition is created. Now with these two partitions, I'm sure that I'm pulling data where product sales is less than $10,000. Now I have to make sure, I can't take chances, so I have to make sure that it is pulling all the records. So for that, I'll create one more partition which will pull the data where it is greater than or equal to 10,000, where sales amount greater than or equal to 10,000, and here sales data with amount greater than 10,000. Okay, I'll create the aggregations later. Click on finish. Now I created three partitions, and the main point that I took care was creating the partitions are I'm not missing even a single record from my fact table. In such a way, in that way I define the where condition. I've given the where condition. In the first case, it will pull in even minus values. If there are any minus values, it will pull. Why? Because I've given less than 1,000. And in the second case, I've given 1,000 to 10,000. And third case, greater than 10,000, greater than or equal to 10,000. So that's a very important point. And this is the damn worst way of defining the partitions, and you should not go on amount basis. As I don't see any other column to give the partitions here, the best way and the most frequently used way is giving partitions on monthly date, on date key. Okay. And while giving partitions, keep in mind that each partition should get at least something around 2 million records or 20 million, more than 2 million records. There should be 20 lakh records minimum. You should not create partitions for 10 records or 20 records. It is of no use. So keep in mind, it's better if you have 20 million records per partition. More than 2 million records will do the work. Okay. And how you will give partitions based on date? I will give you an example. If it depends on your monthly data or daily data, how much data, how many number of records you are getting into your data warehouse on daily basis. For example, if you are getting some 2 million records per day, then the data warehouse will not store more than last 2 years data, or the cube will not maintain more than last 2 years data. Why? Because for 2 years it is 700 and something days into 2 million records, it will go like anything. Okay. So it depends on the data. If you are getting 20 million records per month, and you can create partitions, and the requirement is like we are gonna get data from the year 2004 to current date, then you have to start creating partitions on monthly basis from 2004 to the current day. How the important thing is how you are going to define your first partition and the last partition. The first partition should be where year is equal to, where date is less than or equal to, less than 1st February 2004, which means it will pull all the data of January 2004, and by mistake if any records got injected into your data warehouse which belongs to 2003 year, even that one will be pulled into your analysis server. And the second partition will be, it should be greater than or equal to 1st February 2004 and less than 1st March 2004. So you are going to cover. Why? Because you don't know when the month ends. It may end on 28, it may end on 29 sometimes. So it's better to go with greater than or equal to 1st of that month and less than 1st of next month. So like that you have to go till the last month, and last month you have to give greater than or equal to, no less than condition. Why? Because if you get next month data, if you forget to create partition, it will pull the data into the partition, it won't miss even a single record. And the other best way of defining the where condition for these partitions when you're defining partitions on time or date basis is where year is equal to 2004 and month is equal to 1. Like that, where year is equal to 2004 and month is equal to 2. Where year is equal to, you will have columns in your data warehouse. You not only have that key date column in your data warehouse, you will maintain all other columns like year, month, quarter, as I showed you in date. If you see this time, you can see everything, month, year, quarter, semester. You can join with this and you can set where month is equal to so and so and year is equal to so and so. Either way is fine, but you have to, the only point you have to keep in mind is you should not miss any record while defining the partition. So this is how you can create the partitions, and it's not there is no restriction that you have to create only this many number of partitions. Okay. Now let's go to the aggregations. While creating the partitions, it asks me whether I have to define the aggregations there itself or the option like I will define aggregations later. So I selected I will define the aggregations later. Now let's see what is the use of aggregations. And aggregations will help you in retrieving the data faster. For example, if you have year-wise, dim time as your dimension and sales amount, fact internet sales as your measure group. So when you create aggregations for these two, the measure group and the dimension table, then it will create as many aggregations as possible and it will store in the analysis server. For example, if you create aggregations year-wise, it will create aggregations month-wise. What are all the attributes you selected? It will create aggregation group by statements, what we have seen while giving reference relationship. I have written a couple of queries to show product name wise data like that. So it will create aggregations and it will store the data. It all depends on how you are going to configure here in the aggregation design. It will have its default aggregation design. If you don't define anything, if you define anything, it will take this and it will do the aggregation design. So if you see here, all these partitions are here. What are the partitions I created using comma separated? And if you already defined any aggregation design, then you have to use assign aggregation design. Here you can see if any aggregation design is already defined. If not, then design aggregations. Okay, on top of what fact tables, what partitions I have to define the aggregations. Okay, I will define aggregation. Same set of aggregations for all the fact tables. Click on next. Here it will show you for what are all the attributes you want to create the aggregation. For example, it depends. See, you have to define aggregations for the attributes which you will use frequently in your queries. For example, if you are going to see month-wise data, then define aggregations for that. Full aggregations on top of that. So it will create as many aggregations possible and it will store in the data analysis server. So whenever you run the query for month and the fact data, then it will directly pull the data and the aggregated data will be there. It will pull the records and it will show you in fraction of seconds. And you don't want Spanish month name wise, so leave that one or set as none. If you set it as default, it will take, as I told you, default aggregation design. It will go with that. And I want to analyze full year-wise, quarter-wise, semester-wise. I don't want semester-wise to be frank. Physical quarter, physical year. So you have to select for what all you need is aggregation design. And once you say, you have to click on next. You have to check the count. How many rows are there? And per partition, how many? Okay, it will give you the estimated count and partition count. This partition count, we split into 3 partitions. It's giving the first partition count. So click on next. This is the important page of aggregation design. So now you say for what are all the attributes you want to define aggregations and what are all the fact data. So you need fact data and dimension data to define aggregations. Why? Because it's just like writing sum of fact data, fact columns, joining, group by dimension attributing. So here you have to define what kind, how you want to define the aggregations. Define aggregations until it reached 100 MB of size. So if you click on start, it will check how many aggregations can be designed within this 100 MB of size and what will be the performance gain. It is saying in 100 MB size it used only 4.1 MB and it designed 25 aggregations, which will increase your performance by 99%. So that doesn't mean if your query is taking, MDX query is taking 15 minutes, that doesn't mean it is going to retrieve data in 1 second. So it will increase the, decrease the time taken for the query to pull the data, for sure that one. But it will, up to 60%, it is ideal one, I can say. Even though you specify 100 MB until 100 MB, it won't continue creating until 100 MB. This is the maximum aggregations it can define here for the dimensions and the data we have and the attributes measures we have. This is one way of defining aggregations. And the next way is performance gain. If you define aggregations until performance gain reaches 60%. If you click on continue, it is saying it has to create only, again it's creating 25 aggregations. Or click on reset and click on start, you can see the operation. It will create aggregations, the number of aggregations that are required to reach 60% of the performance gain. So it is saying it has to create 5 aggregations which will improve the performance by 60%. And it is offering 505 KB. Okay, and the percentage gain is 61%. And the third option is until I click stop. Continue creating aggregations until I click stop. That doesn't mean it will continue creating aggregations even if you be continuing creating aggregations will come after 2 days. It will go to the maximum level. As I said, as I showed for size limit aggregation design, it is saying 25 aggregations is more maximum it can create. And the fourth option is do not design any aggregation. This is the dummy one and you can easily understand what it means. So the ideal way people prefer to go with is 60% performance gain. The default one what they have given is 30%, but until 60 it will give good performance gain. So let's see, I think it will create the 5 aggregations again. And click on next, use some aggregation design and finish. Now this aggregation design is defined for this fact data. Now if you see here, assign aggregation design, add partitions with aggregation design. So I have to click here and assign aggregation design. There is no aggregation designs for this. So you have to, if you want to define any aggregation design for thin product, you can go in the same fashion. And this is the advantages. This is how you have to define aggregations and assign aggregations. And these are the advantages. The main advantage is query time will be reduced. Querying the data from your analysis service database will be reduced. And you have to design it in a proper way. What are all the attributes that you are going to use frequently? You have to set that as full aggregation, full. And if you are not going to use any attribute in your queries, then you can set it to none, so that it won't waste its memory in creating aggregations for that. Okay, this is about aggregations, and let's look at the tab perspectives. If you see, when browsing the cube, this is showing the name perspective. It is not showing, even though this is the cube name, it is not showing as a cube name. It is showing as a perspective name. Perspectives. Here you can see it. Perspective. So what is perspective? By default, there will be one perspective created. and everything is selected. Perspective is nothing but giving a slice of cube to an end user based on its their requirements. For example, I define a very big cube, very huge cube with 50 dimensions and 10 measure groups, and it contains batsman related data, bowler related data, fielders related data, and wickets related data. I have 4 different big measure groups and so many dimensions are there. But what a bowling coach is going to do with batting related data? So it is of no use for him. So he will say, I don't want batting related data, I want only bowling related data. Give me data which will have only bowlers related information. Let's take another example. If I have a company, I designed a very big queue for a big company, MNC company, and it has HR related data, finance related data, and many other. So what finance guys are going to do with HR related data? They cannot do anything. So in that case, you can make use of perspective to slice and give a piece of the cube as per the user's requirement. So for example, as I said, whenever you define a cube, there one perspective will be created by default, and the name will be AdventureWorks DW, that the cube name what you will give. So here it is, AdventureWorks DW perspective. And let's say this is my complete cube information, and I got a client. His name is Lords. Let's say he want to see only sales amount data but not sales count. He don't bother about sales count. And in the same way, you don't want to bother about product measure group at all. And in dimensions, you don't want to see due date wise, you want to see ship date wise. And in ship date wise, you want only hierarchy but not any of the attribute. Whatever the items that the client or end user don't want, you have to uncheck those. There are so many. You don't want any attribute information in the ship date. So you want only hierarchy. I provided only hierarchy. And you don't want any information from the due date and order date. And dim product, you want only color and product name. You don't want product subcategory key. And you don't want rest of the dimensions. Okay. In short, you want only English product name wise and color wise is going to analyze sales amount and ship date hierarchy wise. Now I created this perspective and I named it as lots. Let me process the cube. Close. And if you see the browse and reconnect, you can see the perspective lots here. If you select the lot, the name that I have given, I can see only the items that I selected. That is hierarchy from the ship date and color and product name from the dim product. And the measures, I selected only sales amount. I can see that information. It is creating some problem. Yeah, that's why I have the problem. Okay. Not supply any further information. Let me check this. What is this problem? Let me connect in Excel the best way to connect the perspectives. And I'm going to show you how to connect in Excel and see the data from the cube. Connections, go to Data tab, from Other Sources, select from Analysis Services, give the server name, in this case it is dot, and you have to select the cube name, add work is the cube name, and you can see the perspectives here. Click on the perspective and finish. Okay. Now you can see the sales amount. It is working fine. There is some problem with the browser there, and if you select the color, or you can drag and drop it. So black color, these are the products, and this is the same. So this is how the perspective works. Like you can slice the cube, and you can give a piece of the cube to the end user based on their requirements. And I'll check that what's the problem here. Okay, understood perspectives, right? Now let's go to the translations. The main use of translations is to achieve globalization concept. If you create a cube, there will be by default one translation with the default language set. And let's say people from France, French guys, want a cube and they can't understand English. So they want it in French. So if you click on new perspective, here you have to select for which this particular perspective is French, let's say Canada. Okay, then a new column is added. For cube name, it will ask what is the name. So you don't need to worry much about what we call as AdventureWorks in French. The end users, the clients will send you a sheet saying that if you provide all these column names, all these attribute, dimension, measure names, then they will give you the name in French. So you have to copy that. Let's say if they send an Excel sheet saying AdventureWorks DW, we call it as ADVW, let's say. And this one sales data, they call it like this. I'm giving some dummy names just to give some idea. And if you don't give any name in a translation, in this translation, then the English name will be shown there. For example, for dim product category, I have not given anything, and for ship date, I have not given anything, and for perspective, I have not given anything. Process come successfully. Now let's go to the browser, and everything is showing in English. This is the default language. If you change your local computer settings to the particular language that we choose in that we have chosen in creating translations, like in this case it's French Canada, then the names are changed. And for ship date and the dim product category, I have not given any name in French under French translation. So it is taking the default name, what we have to. And the cube name also, you can see it is ADVW, and these are all the measures. And what about the attributes, where I have to give the names, French names to these attributes. So you have to go to each and every dimension. Here you will find the same translation tab. You have to add a translation, and what we have selected, it is French Canada, and give some names. I've given some dummy names just to show you a demo. The problem here is I've given some dummy names. I don't know which one is date and which one is the other dimension. I have to find out that by seeing the column names, number of attributes available in that. So now this one is processed. and I have to reconnect it. And this one, the names are changed. The attribute names, if you see, it is H, G, G, H, F, S, G, H. This is French. So this is how you have to give translation. And in short, translations are used to achieve globalization concept. You can give different names and in different languages for different countries. And whenever the global settings, global language settings is set to that particular language, then by default cube will be displayed. The cube attribute names and measures names and measure group names and dimension names will be shown in the name with the names what were given in the translations. And perspectives is used to give a slice of the cube to the end user based on the requirements. Instead of giving the complete cube, which is not required for the end user and it will be damn heavy. It will be 100 GB in size or even more than that. So instead of giving access to complete cube, you can give a piece of cube to the end user. And aggregations will improve the query performance. And if you define proper aggregations, the query retrieval MDX query will fetch the data faster. And partitions is very helpful for decreasing the processing time that is taking to process the cube, and even the querying of MDX will be the performance of MDX queries will be increased. So these are all the advantages and the use of these 4 tabs: partitions, aggregations, perspectives, and translations. You are very well aware of the use of browser tab here. And let's discuss about calculations, KPIs, actions in next session.